Science 10, Lesson 11, Synthesis and Decomposition Reactions. So the purpose of the assignment, we want to make sure that we're able to distinguish between synthesis and decomposition reactions, but we also want to make sure that we continue practicing our naming skills. Synthesis reactions. We know it's a synthesis reaction when we see two or more formulas combining to form one formula. Yo, would you like to dance? Sounds groovy. These can be identified by the fact there will only be one product. Decomposition reactions, the reverse of synthesis reactions. In the decomposition reaction, one reactant breaks into two or more products, usually due to the addition of heat, light, or electricity. Man, he has some wretched breath. Hasn't this girl heard of soap? Pew, man! Decomposition reactions are identified by the fact there is only one reactant in the balanced chemical equation. So first, convert into formulas. We have silver, it just says silver, so I look it up on the periodic table and I write down the symbol for silver, which is just Ag. And then I have sulfur, and it says just sulfur, so I do the exact same thing. I go to my periodic table, look up sulfur, and write down the formula for sulfur directly off the periodic table. Now I've got silver sulfide. That is an ionic compound, positive first, negative second, so I'm going to have to look up the positive charge for silver off the periodic table, and it says silver takes a +1 charge. And then I have sulfide. I look it up on my negative list. Sulfide has a -2 charge. So when it comes together, the lowest common charge is 2. So I'm going to need a +2 -2. So I'll need 2 silvers to give me a +2, 1 sulfur to give me a -2. Now balance the equation. I have 2 silvers, so I'm going to need 2 silvers. So I'll place a 2 in front of Ag. I have 1 sulfur. There's 1 sulfur. It's balanced out, so the equation is now balanced. I will now identify as synthesis or decomposition. I have 2 things becoming 1. That is synthesis. Converting to formulas. I've got potassium chlorate to start with. That is a positive, negative. So I look up the positive charge for potassium on the periodic table. It is number 19, and it says potassium takes a +1 charge. I look up chlorate on my negative list. On the negative list, it says chlorate is ClO3 with a -1 charge. +1, -1, they already balance out, so I just need one of each. That's going to turn into potassium chloride. So again, potassium we've established has a +1 charge. Chloride on the negative list is Cl-. +1, -1, they already balance out, so I just need one of each. So potassium chloride is KCl. And that is being added to oxygen. It says just oxygen, that's on our periodic table, but it is highlighted because it is a diatomic. So that means I can't write just O, I have to write O2. Now I balance the equation. I have 3 O's, so it means I need 3 O's on the other side, and that's not going to work because if I put a 1 there, that doesn't give me enough. If I put a 2, that gives me 4, which is too many. So I'm going to have to start again with a 2 in front of KClO3. That gives me 6 O's. So I need 6 O's on this side, so I'll place a 3 there. Now I've got 6 O's on either side. I have 2 K's. I need 2 K's on this side, so I put a 2 in front. And now my potassiums are balanced out, as well as my chlorines, because I have 2 Cl's on either side. Now, identify as synthesis or decomposition. I had 1 thing that became 2 things. That is therefore decomposition. Again, we will start by converting into formulas. Iron, we look up on our periodic table. It's number 26, written just as iron, so we just write Fe. Oxygen, again, also just on our periodic table, but it is highlighted because it is a diatomic, so we write +O2. And that's going to turn into iron 3 oxide. That's a positive, negative put together. Iron can be a 2 or a 3, and remember, the Roman numeral is always our charge. So it's saying we have iron with a +3 charge, and it's mixed with oxide. And when I look that up on my negative list, that is O with a 2 minus. So with a +3 and a -2, lowest common charge would be 6. So I need 2 3s, 2 plus 3s to give me a +6. So I need 2 irons. And to get a -6, I will need 3 oxygens. Now, to balance out, I've got 3 O's. No number is going to work with the oxygen to give us 3 O's. So we're going to have to start again by putting a 2 in front of the iron 3 oxide. That now gives us 6 oxygen. And to get 6 oxygen on the reactant side, I will have to put a 3 in front of the O2. I have a total now of 4 irons. So I will need 4 irons on the reactant side, and our equation is now balanced. Now I have 2 things becoming 1, so that is synthesis. And that's the end of the lesson. You're good to move on to the assignment.